Hi folks, so this morning I started out making a video which could have been entitled How Not to Restring a Tuner. Now I don't like restringing tuners, I'm not good at it. As I commonly say, I am not good at working with anything that has moving parts like tape decks or women. Okay, so I was very careful when working on this unit not to damage the tuner string. I'm going through a complete rebuild on it, and I made sure that when I was soldering anywhere within the same zip code as the tuner string, I covered it with aluminum foil to make sure I didn't accidentally hit it with the soldering iron and damage it. So after I was done with all my soldering, I started looking at the tuner, and I ran the tuner all the way up to the far end, and the string broke, proving yet once again that Murphy of Murphy's Law just has it out for technicians. So anyway, I went through the process of restringing the tuner and failed multiple times, all caught on camera, all left on the cutting room floor as it were, because as it turns out, not only is there a problem with the tuner string, there's a problem with the tuner itself, and I'll show you what that is. This unit's been a fight to the finish. When I got to the phono board, I had some very serious motor boating issues. Motor boating is where you have like a put kind of positive feedback. And there was a gentleman on a forum who went by Cat Rafter, Tom Wilson. Tom, I give my thanks to you. You made a post where you pointed out that Marantz and later iterations put a couple of 47 ohm resistors on the outputs of the tuner of the phono board to provide isolation and prevent this kind of thing from happening. Sure enough, I put them on here and it stopped that problem. So now we got to take a look at the tuner. I'll show you what the issue is. The manual states that we need to input an FM modulated signal between 87.5 megahertz and 108.5 megahertz. That's each end of the FM band on this tuner. And it needs to be a very low level. They say between 3 and 5 microvolts. This generator goes from 100,000 kilohertz to over 1 gig. So it has a type N output connector here. Now, since we're never going to go over 108 megahertz, we can use B and C, and I have a type N to B and C adapter. The other thing you need to know is the generator has an output of impedance of 50 ohms, and the antenna input on the receiver is 75 ohms. So we need some way to adapt it. There are several different ways. I chose to make this low loss network, which I found on Brian Beezley's website. Brian is very, very knowledgeable on RF. I will include a link to the site I found. And I made this. He said the loss is negligible, about 0.05 dB. We often, in fact, most of the time don't need absolute value. So I don't even bother to calculate. I just input it and go on with my day. Now we're coming out of here, 75 ohms, B and C, and we have to go to our 75 ohm to 300 ohm with our matching transformer. Anyone that's ever gotten cable TV in the early days has seen one of these guys. So we're going to use that. So we have type F here. I'm sorry, geez, it's early in the morning. B and C here, type F transformer, and this is going to go into the back of the receiver. So we take our low loss pad, we come out of our 75 ohm, we come out of our 50 ohm, we come out of the generator here. Now we set our generator frequency 87.5 megahertz, and we're going to have to go between 87.5 and 108.5. So we're going to input an interval frequency 21 megahertz. Frequency 87.5 megahertz, frequency interval set 21 megahertz. Now these arrows will increment and decrement. 108.5, 87.5, just that quick. We need to have let's see, an amplitude of 5 microvolts, and we need FM deviation of 75 kilohertz. So now our generator is putting out what we need it to put out, and I just need to hook up to the back of the receiver. So we're going to go down here. Now this has these little spring clips. I'm not a huge fan of these, and it's kind of a pain because this guy has forks for screwing onto screw terminals, but we can make it. Okay, so we got our fork terminals on. That was way more painful than it needed to be. All right, the other thing we need to do is we need to look at the output of this on an oscilloscope. Now we only need to look at one channel, so let me turn the scope on, and we're going to take a look at one of the tape outs. No need to see both until we get to the stereo. Okay. And we only need to see one channel, so I'll turn one off. And here we go. Turn the receiver on. And we need to tune it all the way down. We see nothing. I'm going to turn the amplitude of the generator up a bit. I don't see our signal. See what looks like a radio station. So I think we probably have to twist one of the cores. Here's our signal. Okay, I'm going to turn this up a little bit. And there's our signal. I'm going to drop the level down. Okay, now as you drive, this is why you need to use a really low level. Okay, that looks good. Let me keep dropping the level. Okay, I'm down to 20 microvolts and it looks pretty crappy. Okay. This is our problem. We don't have sensitivity. That's 40 microvolts. And it's starting to get a little ratty. So let's see where our problem is. Okay, so I've got some noisy test equipment on. This is my RF generator. I'm feeding in 108.5 megahertz, which is the far end of the FM dial. And I'm feeding in 1 millivolt, which is a very strong signal. And I am picking this off at the output of the tuner in the Marantz with the spectrum analyzer. So I'm just going to move you over here so you can see that. And if you can read the display here, it's probably a bit of glare, but you can see our marker is showing we have a neg 47 dB. Now, I also have my test tuner here. I don't know if I've ever shown you this or if you've ever seen it, but basically it's a tuner I pulled out of a carcass I got from a gentleman I know. And I'm going to take the signal generator, feed it into that. We're going to pick that off with the spectrum analyzer and see what that looks like. So I've got the signal connected in, and now we're going to take the spectrum analyzer probe and put it on the output here, and look here, we have a neg 39 dB. So we're getting more output out of our test tuner, and I was getting better than that. Yeah, there you go. I have a bad connection here. There you go, neg 20 dB. So I'm getting significantly more output out of my test tuner. So we have a problem in the tuner itself, which is going to necessitate taking the tuner string off. Now I did restring it successfully, but the string I used had a bit of give to it. So I'm going to have to try something else. I'm going to try some braided fishing line, which I've heard anecdotally gives good results. But in the meantime, we got to fix the tuner before we even think of restringing it. So we have a problem in the front end of the tuner. Okay, so when I'm talking about the front end of the tuner, I'm talking about this section right here. You have your RF amplifier here, local oscillator here, and mixer here. And in block diagram terms, this provides amplification of the signal from the antenna and a bit of buffering, I'm sure. And then we have our local oscillator. Now that's going to be running, I believe, at 10.7 megahertz. And our mixer is a nonlinear device. It's a FET that's running in nonlinear mode, so it's going to take the signal coming in, it's going to beat it against the signal from the local oscillator, and what this is going to do is it's going to spin off sums and differences. And the difference we're looking for should always be at the output, the IF frequency of 10.7 megahertz. So our problem, I believe, is our RF amplifier is not giving up the goods. This is where most of our gain should occur. So I need to just take a look at this circuit and see what's going on. Now, I did a video on a Marantz 2265B that had a lack of sensitivity in the front end, and it had a dual gate FET, and the voltages were wonky. The DC voltages here don't look that bad, but it's possible that the FET has lost some gain over the years. I do have some of these 2SK19s, so I may just try changing that out and see if it helps. But anyhow, that's where we're going to start. Now I'm feeding my signal into the 75 ohm inputs on the receiver, and I'm just using a piece of cut coax cable with a type F connector on one end and just bare wire on the other. And at 40 microvolts our signal is rock solid. At 20 microvolts our signal is rock solid. At 10 microvolts, 5, 3, we still have a rock solid signal. We have a problem in the 300 ohm antenna input on this receiver. At 75 ohms, everything is beautiful. I'm putting out 3 microvolts now. I'm going to drop it. 2, we're just starting to see it break up. So this tuner is extremely sensitive now. Now we need to check at both ends, so we run the tuner all the way up the dial. And you go back and forth like this. That's why I like to set my generator, so all I have to do is just hit the up button, and I'm all the way there. Now we're receiving a radio station here, so we're going to have to go back and forth. You adjust the coil on the low end, capacitor on the high end. You have to do this several times, and after a restring you have to do this. And it takes a while. In fact, I need to turn the level back up to at least 5 microvolts, because it may not be as sensitive at the high end, and this is a very touchy adjustment. There we are. So yeah, that was the whole problem with this receiver, was the antenna input. There's something wrong with the 300 ohm. I'm not that inclined to mess with it. I'm going to make sure that it's marked clearly on the back that only the 75 ohm input works. Well, when I pulled this tuner out, I learned something interesting, and that's the fact that I was not the first one to pull this tuner out. This front end had been removed before, and I knew that because from the factory, these wires will be wrapped around the lugs and soldered, but they were just laying there and soldered on, which made them a lot easier to get off, but also told me I was not the first person to be in here. I did replace the RF amp. It did give me a little more gain, but it turns out that the problem was not actually in the front end, but rather in the back here. And I don't know what the problem is yet, but I was able to use the 75 ohm tap instead of the 300 ohm I usually use, and as soon as I did that, I had strong signal right here at the front end. So there's something going on back here. I'm not real inclined to screw with it. As long as it'll work on the 75 ohm tap, I'm happy. And this tuner is now getting really good signal. One of the things that threw me for a loop here is I was barely getting any signal on the meter in the front. But the problem with that turned out to be, now this is, let me step back for just a moment. That was with the test front end that I have. And I still didn't get a lot of signal on the meter. And it turns out that the pot back here, and this is the adjustment. It doesn't tell you in the manual what it is, but I believe this is R531. I'll have to take a look at the schematic. But that was the adjustment for the meter. And all I did was scrub it a little bit back and forth, and the meter works fine. I don't like these open frame pots. They tend to get dirty or tarnish or whatever they do a lot easier than the closed ones. So now that I did that, we have really good signal strength. If you look here, I'm going to lower the camera a little bit, and you can see we have good signal strength here. I don't have a string on the tuners. I've been tuning this by hand, but I get a lot of stations, in stereo. So the problem was probably the 300 ohm tap. I did get a little more gain by replacing that FET, but I don't really think the old one was bad. So anyhow, that's the problem with the tuner. I'm going to go through the stringing process, show you how we do that, and I may mute the video because I'm going to curse like a sailor when I do. Okay, so here's the stringing diagram that comes in the service manual, and I've done this probably 5, 6, 7 times on this unit, so I could probably do it with my eyes closed. But you start out here, and there's a little tiny hook and eye here, and I'll show you that before I'm done. And we run the string through here, around these pulleys, 3 turns around the tuning flywheel here. And we have to go around this way, so we have to go counterclockwise 3 times, return here, and then we go here, and they give it an exploded or a larger view of this. And it's very important that you follow this, because I didn't, and it caused me a lot of heartache. But you go around here once, and if you follow the line, you'll see the first thing you do is go down and pick up the spring here. And then you go around 2 more times before you go out. I had gone around once or twice, then got the spring on the last one. It doesn't work. Trust me, it does not work. And then when you come out of the wheel here, you go up and you go around this pulley here, and then you finish up with a hook here. And what I've been using for that, and I can't believe I still have any left because I did this a lot of times, is what I did is I took one of these eyes, the crimp on, and I just cut the eye part off and just left this part here. And that way I can crimp the string. Now, I'm not sure how well it's going to work on this fishing line because it's pretty small in diameter, but I'm going to give it a shot and see if that works out. Now, I'm going to move this out of the way. I'll tell you what, I'm going to stop this and then get the camera off manual focus. Okay, I took a piece of low stick tape and I stuck the pointer down here while I was working on everything else, because I learned the hard way that if you break one of these, you're going to have trouble finding it and it's going to cost you money. I found one on eBay. The guy was in Europe. It cost me shipping, handling, and what he charged for it. And I'm not letting that happen again. So I taped this down here so it wouldn't come to any harm. It's still wired up to the light, so I couldn't just shut it off to the side. So we're going to start right over here. And I usually just take the line and I clamp it to the rail here with a pair of hemostats, and then I can work and keep tension on it. When I bring it around, and then I can loosen it up. And then I put the pointer on as the last step. Now, I'm not sure how well that's going to work, because I don't think this line is going to have as much give as the other stuff did, but we're going to find out. Okay, so here's that little hook I was talking about. I finally found it. I put it in a safe place, and that's usually the kiss of death. However, I did remember where that safe place was, and I got the hook, and this is what it looks like. It's got a hook on one end and a ring on the other. And the first step that we take is that we are going to take this line here and tie it through the ring end. And I have done that right here. And then what we have to do is we have to put a dab of adhesive on it to make sure the knot doesn't come untied. I use hot glue because it's what I have, and I'm glad I did because I've had to remove it several times, but it does seem to do a pretty good job. So I'm going to put some hot glue in the end of this, trim off the excess, and then we're going to lay it across here, take a set of hemostats and clamp it into place. Okay, I've got the line clamped down here with the hemostat, so I can put some pressure on here. You probably can't even see it. I can assure you I have some line in my hand here. We're going to start looming it through here. There's a couple of pulleys around here, and I have a picture of them I can show you here. And we have to go around the one and down the other. All right. So there's 2 pulleys under here. We go around this one, 3 turns counterclockwise around the tuning wheel. And then we come out and go around here. So I'm going to go do that. Okay, so I've got it from here, around this little pulley, 3 times around here, counterclockwise. If you go clockwise, it'll still work, but the tuning mechanism will be backwards. So as you're tuning up, the dial's going down. So if you want it to work right, you got to follow that diagram exactly. And that tells you counterclockwise. So I've got it around this pulley, around this one. I have it clamped here. And now we have to go around here and up and grab the spring. So I'm going to do that. Then we do 2 more wraps, go around, and we go down here to this pulley, and then we're going to clamp it. Wish me luck, folks. This is usually where I screw it up. Okay, so I got it strung, and I'm going to show you a picture here of what this looks like down here, because that was the final thing I had to do, was get the eye clamped on. Once I got it run through here, and the trick is you have to loop the line through that little crimp that we're going to do. So it's going to be looped in. It's really hard to see this, but anyway, you have to take your line and you have to loop it real tightly and push it through the eye that you're going to crimp down. Then you can pull it tight. All right, you can pull it tight, then you can crimp it. And once I did that, I put a little hot glue on each end to make sure it stays. And the tuner looks like it's going now. I'm just going to put this on so you can see I turn the wheel, pointer moves, getting our stations. I'm going to have to go through the dial alignment, but it wasn't bad. The 8th time apparently is a charm. It really helps to have hemostats to give you tension, so as you're running it, it doesn't come out of where you're working. And it's very important that on that little spring down here, you go through on the first loop. If you follow these directions, and thank God they're pretty good, it'll work out okay. I had to put some hot glue here to hold the pointer onto the string. It's a really fine string, and you may be better off using something else, but this stuff doesn't stretch, and there's a lot to be said for that. So anyhow, I got the string in. I didn't lose my last nerve as I have on other tasks in the past, and I'm going to stop this video now. I think this thing is finally done. I'm not sure well you can see this, but I've done the output boards. I got new output coupling caps, new filter cap. Found the problem with the tuner. I'm just going to tell the guy that's buying it just to use the 75 ohm taps, and if he needs some adapter, I'll give it to him. So anyhow, folks, that's it for this one. I'm going to edit this and put it up. And as always, I thank everyone for watching. And I like giving back to the community that's given me so much. Thank you very much. Okay, so I actually moved the hemostat over here so I could get some room, because we need to secure this end first. We're going to put this through the eye part of our hook and eye assembly. You remember I showed you this. So we're going to loop this part through there. And I made a little mark right here so I know if this is about where we want this indicator to be. And I'm going to take this and I'm going to put it through the eye here. And got to tie a double knot in it. And got to make sure there's enough slack to go there. Right about here should be good. As I said, this video may be how not to restring a tuner, so we'll see how this goes. Okay, so I want to make sure this is good and tight, and put another knot in it, and then we put a drop of hot glue on and This would be a good time to mention when we do the other side. Let's make that nice and tight. Get it straight there. So I'm going to put a drop of hot glue on this just to keep the knot from untying. Like I said, they had some kind of goop on here. Hot glue is the closest thing I have. And we'll cut the excess off here. Whatever reason, my wire cutters don't cut this stuff all that well. And that little hook has an affinity for everything. Okay. So when you do this, try not to cut the wrong side. Please don't ask me how I know that. Okay, so I'm just going to cut this end. Probably use some new scissors. Okay, so here we have the one end and the other end, and this is what, be sure before you do this to put your sleeve in. Remember, we're going to use a piece of heat shrink. Put this on first. I can't tell you how many times when I was younger. So what we do here is I take this guy here, I'm going to cut the eye part off so we just have the little sleeve, and that's what I'm going to use to crimp this. Now we have to get the string through here in a loop, so we feed it through once and then try to feed it through the other way, and that never works, so I made something to use. I took a piece of old component lead, and I keep this stuff handy. Take a piece of this, I just made a little hook in the end, and I can slide that through the eye. So basically what I do is I take this here and I feed it through here like this, and then I can take the string and lay it in there and pull it through. Okay, so I got the string in there, and now I should be able to pull it through. Okay, and I was able to get that through. So now what we have looks like this. We have a hook, or loop, I'm sorry, and this loop is going to allow us to go on to here. Okay, here's my first mistake. I need to be under here. This is the power for our indicator light. So you want to make sure that your path is good. And we pull this, and we should get a little tension on the spring when we do. Well, I've got it clamped, so we're not going to see that. But anyway, if I take this guy off here, we should be able to pull this and get a little tension on the spring. Okay, feels pretty good. All right, so I am going to crimp this. For that, I use the tool here that we use for crimping these, and we're going to put it right up here. We're going to crimp our string like that. And one more for good measure. Okay, so our string is crimped now. We should be able to let it go. We have tension. Now we feed it under our indicator and hot glue it in.